Lecture 12, the main topics that we are discussing, the sum of product expression, uh, how we can determine the domain of an expression, convert any sum of product expression into standard form, and same thing in product of sum expression. Okay, the SOP and in short we'll call it as an SOP and POS forms. These are the two main representation that we used in Boolean algebra. Okay, we'll see all these things in this particular lecture. Okay, we'll start from here. Standard forms of Boolean expression. There are two different methods or different way we can represent a Boolean expression. The two methods are known as one is known as a sum of product form, and the second one is known as a product of sum form. In short, we will call it as SOP and POS form. So throughout the lecture, we will use these words SOP and POS. SOP means as a sum of product, and POS means as a product of sum. Okay. Why we are going for the standardization mean? Because evaluation and simplification. Okay, the Boolean expression simplification and evaluation will be in a systematic way. Okay, if you use a standard notation and expressions, and it will also make the calculations easier. Okay, these are the main points why we are going for standardization. And first we will discuss sum of product form. In sum of product form, okay, when you write in a Boolean expression in SOP form, it contain two or more product terms. Okay, and product term means basically the and expression are summed by Boolean addition. Boolean addition means the OR operation, not binary addition. So this is not binary addition. This is simply Boolean addition, which means it's an OR operation. And the resulting expression is known as the sum of product form. So I'll give you some example. Here you can see that it's AB plus ABC. So here you can see one AND expression. Here you can see another AND. These two AND expressions are combined by an OR operation. Okay. So if you take the logical diagram, it will be like this. One AND gate, two inputs AB. Okay. And another AND gate, three input A, B, C, and we are combining these two inputs by using an OR gate. This is OR gate, this is AND. So here it is AB, here it is ABC. So if we combine these two, AB plus ABC. Okay. So this kind of expression is known as sum of product. So there will be and first level there will be AND gate, and second there will be an OR gate, single OR gate. And similarly, you can see other expression. Here it is ABC plus CDE plus B bar CD bar. And another expression A bar B plus A bar B C bar plus AC. So all these expressions are examples of this sum of product terms. So you can see that two or more product terms are summed by the Boolean addition. The resulting expression is known as SOP form or sum of product expression. Okay, two conditions or two cases we will discuss here. Even if it is only a single variable, we can consider as an SOP form. Here you can see there is no product term actually, but a single A. So this single A I can write like this, A into A. So this can be written as an AND form. So we will consider this expression also in SOP form. But if there is an expression like A, B, C, the whole bar. Okay. So we will not consider this as an SOP expression. SOP expression means individual variable can have this bar, A bar, B bar, C bar, and it cannot extend to more than one variable. So if there is a variable A, B, the whole bar, we cannot consider as an SOP expression. Okay. So make sure that you are going through this examples, A plus A bar, B bar, C plus B, C, D bar. There is only single variable that we can consider as an SOP form. But if there is a whole bar, ABC, the whole bar means in order to implement this, we need an AND gate. So by using and or, we cannot implement this particular function. That's why we will not consider this ABC, the whole bar, as a SOP expression. Now we can see here a circuit is given, and we need to verify this in a SOP expression. This is the standard form of, there will be AND gates in one level, and another level there will be an OR gate. So in the first case it is an AB, this is one BCD, and third one AC. See, and we are giving all these outputs to the input of the second OR gate, and the output will be the AB plus BCD plus AC. Okay, this is an example for sum of product realization. Now we need to convert each of the following expression to SOP form. So we'll take the first case. So here you can see then AND gate AB. So this is an AND operation, but here if you look at here, it's B into CD plus EF. So we need to convert it into standard form, SOP form. So we can multiply B with CD and B with E. Multiplication means an AND operation. So when you perform this operation, you will get AB, BCD, and BF. Now it is in the SOP form. AND operation. This is AND operation. This is AND operation. This is AND operation, and here you can see OR. Okay. So this is in SOP form. Now we can consider the second question. Here you can see that OR and then AND operation. So we need to convert. So we can apply the rule A and we can perform A with B, then AC, then AD. Okay, just like normal algebraic multiplication you can perform. Here you can B, BC, and BD. So, okay, by applying the distribution, we can expand the expression like this. So now we are getting AB, AC, AD, BB, BC, BD. Now it is in the sum of product. Now we can consider the third question. Here it is A plus B the whole bar plus C the whole bar. So now we need to apply the De Morgan's theorem here. De Morgan's theorem said that x plus y the whole bar is equal to x bar into y bar, and xy the whole bar is equal to x bar plus y bar. So first we can take the whole bar. So if you apply that, first if you apply De Morgan's theorem to the first bar, you can split it into two. Okay, and C bar. Now we can see that here is double negation. Okay, if you perform not operation twice, you will get exactly the same. So it becomes A plus B into C bar. Now we can perform like B C bar and A C bar. So the two expressions. Now it is in the SOP form. Okay, now we'll move to the next one. And now we'll discuss what you mean by standard SOP form. Okay, so there are two types, SOP and standard SOP, or we can use one more name, is known as a canonical form. Okay, canonical SOP form or standard SOP form. So what is the difference between SOP and standard SOP? I think better we can go for an example, and this is the definition. Or a standard SOP expression is one in which all variables, okay, in the domain appear in each product term in the expression, either in the complement form or in the directive. Okay, and why we choose the standard form? Because for constructing the truth table and for writing the K-map, K-map is actually a simplification method used in Boolean algebra for the minimization, and for these two applications we required a standard SOP form, not as SOP form. This is standard SOP form. So we'll see what is the difference between SOP and standard SOP form. So here you can see this is convert the following Boolean expression into standard SOP form. So the question is given in SOP form, that is clear. But if you closely observe this particular expression, Here you can see that A, B, C variable is included. Here also A, B, A, B, C, D. So we can conclude that this particular function contain the variable A, B, C. But in the first part, there is only C. There is no D component in this particular expression. If you observe the second one, there is no C or D variable. Okay, in the last expression, we can see that all the variables are included. So we need to express each product term by using all the variables. Okay, either D or D bar or C bar. It should contain one representation from each variable. So we'll see this. So first we need to identify the domain of the expression. So this is ABCD is the domain of the expression. So first we can take A, B bar, C. Okay, we'll take the first A, B bar, C. And if you closely observe this particular D is missing here. D or D bar. Okay, so we will include a term like this D plus D bar, and D plus D bar means by Boolean laws we know that is equal to 1, and if you perform AND operation with 1, okay, there is no change, A dot 1 which is equal to A, so your expression will be same as A B bar C. If you add an extra term like this D plus D bar, your final answer will be same as A B bar C. So when a variable is missing, please use this kind of notation, a variable plus its complement. Okay, now we can multiply this, or we can perform AND operation. So A B bar C into D, this is one expression, and another expression A B bar C into D bar. Okay, you will get another. So this A B C you can expand into two different terms. Now we can consider A bar B bar. If you consider A bar B bar, actually Z is missing and D is missing. So first we can include C. Okay, uh, later we can add D also. So when C is missing, we can add a term like this, C plus C bar. Okay, C plus C bar, which is equal to 1, and if you perform AND operation with A bar B bar, you will get exactly the same result, A bar B bar. Now we can expand this. Okay, so you'll get A bar B bar C plus A bar B bar C bar. Okay, and uh, later, so now we can see that in this particular expression, D is missing. So here also D is missing. So again, we need to add a term which contain D. So we need to add the D terms. Okay, in order to add D terms, uh, we will use D plus D bar. D plus D bar, because these two terms, in these two terms we need to add D. So we can add D plus D bar here and D plus D bar here, and we can expand. So we can expand this. So finally you'll get A bar B bar C D, A bar B bar C D bar, A bar B bar C bar D, then A bar B bar C bar D. So the second expression, if you expand the first expression, you will get two terms, and the second time if you expand, you will get four different expressions. Okay, and the final one contain all the variable, so we don't want to do anything. You can simply keep that term like this. So if you write the expressions, finally you will get uh, 1 2 3 4 5 6 7 different terms. Okay, so total 7 terms. So the 3 terms we can expand into 7 terms, and all the product term contain all the variable A B C D. Here if you verify this, you can see that all the terms contain A B C D. So this kind of expression is known as the standard SOP form. Okay, which is different from simple SOP. If it is not in standard SOP, it's known as SOP expression. Okay. Okay. Now we'll explain the second one. Determine the binary value for which the following standard SOP expression is equal to 1. Okay. And when you write any SOP expression, you will always check when the output is equal to 1. Okay. Here, an expression is given or a function is given. A function f is given ABCD plus A B bar plus C bar D plus A bar B bar C bar D. And we need to find out this particular function value is equal to 1. Okay. So in order to get this 1 at the output, what should be the values of ABCD? Or what should be the value of this ABCD first term, second term, and third term? Okay. So for that, we need to analyze the expression. See, in order to get this output is equal to 1, either this first term is equal to 1, or the second term is equal to 1, or the third term is equal to 1. Or it can be all the terms. Okay, or one or more terms. The output is 1. Okay. So this is OR operation. This is OR operation. This, if any one of the input is 1, the output will be 1. So we got a condition like ABCD should be is equal to 1. So in order to get ABCD is equal to 1, we know that here A is equal to ABCD. If A is equal to 1, B is equal to 1, C is equal to 1, D is equal to 1, and if you perform the AND operation, you will get answer is equal to 1. So in order to get output is equal to 1, if you're considering the first term ABCD, A should be 1, B, C, D is equal to 1. Similarly, we can consider the second term A, B bar, C bar, D is equal to 1. In order to get A, B bar, C bar, D is equal to 1, uh, we know that A is equal to 1 and B bar is equal to 1. So in order to get B bar is equal to 1, B should be equal to 0. When B is equal to 0, B bar is equal to 1. Okay. In order to get C bar is equal to 1, C is equal to 0. Okay. Then C bar is equal to 1. In order to get D is equal to 1, D should be equal to, sorry, not 1. So that should be the values of A, B, C, D. And if you perform AND operation, 0 bar, 0 bar, you will get 1, 1, and finally the expression will be 1. Similarly, the last term. So if you take the last term, A, B, C, D, the whole bar. So in order to get A bar is equal to 1, A should be equal to 0. Okay. And B bar is equal to 1 means B is equal to 0. C bar is equal to 1 means C is equal to 0. D bar is equal to 1 means D is equal to 0. So A, B, C, D value should be 0, 0, 0. For this value, you will get 1. So either A, B, C, D is equal to 1, 1, 1, you will get output 1, or A, B, C, D is equal to 1, 0, 0, 1, output will be 1, or A, B, C, D is equal to 0, 0, 0, your output will be 1. So the SOP expression is equal to when any or all of the three product term is equal to 1. So we need to identify this values to make the truth table and all. Later we will see this question in detail. Now we'll move to the other part, the product of sum form. Okay, POS form. And already we mentioned that when two or more, in the previous case we discussed when two or more product term, now it is replaced with sum terms. Okay, are multiplied, the resulting expression is known as a product of sum. In the previous case, it is an and or operation. Now it is changed to or and. Multiplied means it's an and operation. Okay. All these expressions are logical expressions. Sometimes it's a logical or operation. Multiplication means an and operation. Okay. This is POS. And you can see that example. So here you can see a sum term. Here also sum term. And we are performing and. So this is an OR operation. This is an OR operation if you consider up to this much. And we are ANDing. And similarly, you can see that this is an OR term. This is OR and this is OR. And here you can see AND. Here also you can see AND operation. Okay. So last time also you can see OR, and we are multiplying. So the AND operation. Okay. We can draw this one circuit. Initial step, we need an OR. So A bar B, then next variable is A B bar C. Okay, and it can combine all these by using an AND. So this is known as the first level we are using OR, second level we are using AND. This is known as the POS form, product of sum form. Okay, and in the POS expression can contain a single variable term like a bar, okay, or a itself. So there is no restriction for a single variable. By using a bar or a, we can include. There is no compulsory. That means if you take a, and OR operation, the output will be a. Or similarly, if you perform a bar, the output will be sorry a bar. Okay. So by using a single variable, I can expand it in an OR operation. So this can be considered as an POS expression. But similarly, in the case of AND, if there is a term a plus b plus c the whole bar, we cannot consider this as a POS expression term, because we cannot perform this a plus b plus c by using OR and AND operation. So it can be like this: a bar plus b bar plus c bar can be one of the term, but a plus b plus c the whole bar cannot be the POS form. So this is one expression which show the POS form, product of sum OR operation, and here it is AND operation. Can verify this. This is a plus b here, and the second one is b plus c plus d, and the third one is a plus c. Okay, and finally we are combining all this by using an AND gate. Okay, so you can see the AND operation here. Now we will convert the following Boolean expression into standard POS form. So the given result is not in standard POS form, just like in SOP. And what do you mean by standard POS form? Okay. So in the question, you need to verify that the final expression should be in POS or standard POS. These are different. If it is simply POS or standard POS form. Standard POS form and POS form are different. So always make sure that which one is given, whether it is a POS form or a standard POS form. So this is a question: a plus b bar c plus b bar plus c plus d bar, and a plus b bar plus c bar plus d. So we can identify that variable domain is a b c d, or it's a function of a b c d variable. But if you observe the first term, there is no d term, okay, d or d bar term. Similarly, if you observe the second term, there is no a or a bar term. So we need to include that also. Okay. So for that, first we identify domain. Second, we observe that here d is missing. So in a POS form, we will add a term like this: d bar. D bar means which is equal to 0. And if you perform OR operation with 0, okay, OR operation with 0, there is no change in the output. Okay, if a plus 0 is equal to a, so we can add a 0 here. Okay, there is no change in the expression. In order to replace this 0, d into d bar is equal to 0. We can include that term. Okay, and now we can apply the distributive law. Now we will get a plus b bar plus c into d. This will be one term, and another term a plus b bar c plus d bar will be the other term. Okay. Now we can verify the second term. If you consider the second term, in second term a is missing actually. So in this expression a is missing. So we can add a plus 0, and you want to replace this 0, I can add a bar. So this is a bar. Now we can expand this by distributive. So a plus b bar c plus d bar. This will be one term. Another term will be a bar plus b bar plus c plus d bar. Okay. Uh, Now we can explain another thing, the last term. So, okay, the last term is a plus b bar plus c bar d, which is in the standard form because all the variables are included. So we don't want to change. So first expression we expanded in 2, second also 2, last one will be the same. So finally the expanded term contain 5 terms. This first term expansion, this is the second term expansion, this is the original last term. So total 5 terms. So this is a POS form expression. Okay. Now we need to identify the binary values for which the function uh, result into 0. Okay. When you consider POS expression, you will always check when the function value is equal to 0. So please note down the difference. When it is an SOP form, we'll check for the function value is equal to 1. When it's a POS form, we'll check for the function value is equal to 0. Means we need to get the output of this particular function is equal to 0. Means either this term is equal to 0 or the second term is equal to 0 or the third term is equal to 0 or all the terms can be 0 also. Okay. In order to get the first term is equal to 0, okay, ABCD is equal to 0. Uh, the first term is equal to 0 when a equal to, and one more thing, this is a sum term. Okay, in order to get the sum term is equal to 0, a should be is equal to 0, b 0, c 0, d 0. Then sum is equal to 0. Okay, so ABCD should be is equal to 0, or when ABCD is equal to 0, the function value will be 0. And similarly, the second term, a plus b bar plus c bar d is equal to 0 when a is equal to 0 plus b bar is equal to 0 when c bar is equal to 0 when d is equal to 0. So in order to get a is equal to 0, a equal to 0. When b bar is equal to 0 means b is equal to 1. When c bar is equal to 0 means c is equal to 1. When d is equal to 0 means d is equal to 0. So 0, 1, 1, 0 will also result into function value is equal to 0. Now the third term, a bar, b bar, c bar, d bar should be equal to 0. So in order to get this term is equal to 0, a bar 0 plus b bar 0 plus c bar 0 plus d bar 0. In order to get a bar is equal to 0, a is equal to 1. B bar is equal to 0 means b is equal to 1. Then c bar is equal to 1 means c is equal to 1. And d bar is equal to 0 means d is equal to 1. Okay. So when the function a, b, c, d values are 1, 1, 1, 1, the output is equal to 0. Okay. So when you are considering SOP expression, I'll repeat, the function value should be is equal to 1. When it is a POS form, we'll check for 0. Okay. Now we need to develop truth table from SOP expression. So how we can write SOP, sorry, how we can write truth table using SOP. Okay. Here you can see that there is an SOP expression is given. Okay. So first we need to identify the domain of the variable. So here it is ABC, means 3 terms. So we can consider this as the input. Okay. And corresponding output we need to write. That's a truth table actually. Okay. Truth table means it contain input and output. So ABC means a 3 variable. So if n is equal to 3, 2 raised to 3, 8 different combination will be there. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. You will get different combinations. Okay. But if you observe this particular term is an SOP expression, we can easily find out the function value is equal to 1. When will be the function value is equal to 1? So in order to get the output is equal to 1, either this particular term is equal to 1 or the second term is equal to 1 or the third term is equal to 1 or any other term or all the terms can be 1. So in order to get the first term is equal to 1, a value should be 0. If a is equal to 0, a bar is equal to 1. When b is equal to 0, b bar is equal to 1 and c is equal to 1. Okay. So 0, 0, 1. 0, 0, 1, the output function value is equal to 1. Similarly, the second time, a, b bar, c bar, when a is equal to 1, b, okay, a equal to 1, b bar. So b should be equal to 0 and c should be is equal to 0. So 1, 0, 0. 1, 0, 0 also result into 1. And the last time is ABC. So A, B, C should be 1, 1. So these are the three different cases where the function value is equal to 1. And in all other cases, the function value equal to 0. So by in this way, we can simply write the truth table. So only thing we need to identify the product terms given in the expression and when we will get a 1 for that particular product term. So here you can see that A bar, B bar, C, A, B bar, C bar and A, B, C. In all other term, you will get 0. Okay, so this is the truth table representation of SOP. Now we'll go for a POS, a similar case in POS. In the case of POS, actually we are looking for a 0 value, okay, not a 1. POS always we are looking for. So in order to get this expression is equal to 0 because it's a POS expression, standard POS expression. So the function domain is A, B, C. So these are the inputs and this is a function value or output case we need to verify. Okay. And here we need to get the output is equal to 0. So in order to get the output is equal to 0, the first term, okay. So this expression value, okay, ABC term is equal to 0 when A equal to 0, B is equal to 0, C is equal to 0. So when A, B, C is equal to 0, the function output is equal to 0. So A plus B plus C. Okay. And second term, A plus B bar plus C is equal to 0 when A is equal to 0 and B is equal to 1 and C is equal to 0. So A equal to 0, B is equal to 1, C is equal to 0. So 0, 1, 0. 0, 1, 0 will be this term. Okay. And similarly the other term A plus B bar C bar is equal to 0. Okay. When A is equal to 0, B is equal to 1, C is equal to 1. So 0, 1, 1. 0, 1, 1 will be the other term. In the similar way, we can identify the other two terms also. 0 for A bar B plus C bar, it will be like this. And the last term 0 A bar B bar plus C will be this term. So we got 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So 5 terms, the output will be 0 and all other values will be 1. And if you observe the truth table of this question and the previous question, okay, you can see the same truth table. Means same function I can express in SOP form or POS. Okay, if you take this, either I can say the function value gets 1 for the term A, B bar, C, A, B bar, C bar is equal to 1, A, B, C. That is the SOP expression or this POS expression. So both represent the same quantity. Okay, so Boolean expression can be represented in SOP or POS form. So if it is in the standard form, it's very easy to write the truth table. So that's why we are writing expression in the standard form. Okay. Now, from the truth table, we can determine the standard SOP expression and the equivalent standard POS form. So we already wrote the SOP. From SOP, we got the truth table. Now we need to write the standard expression from the truth table. So, okay, for that, in order to write the SOP expression, so first we will try SOP expression, and the second part we will try for POS. So in order to get the SOP expression, so this is the truth table given. We need to check function value is equal to 1. So we are getting 4 different cases. So for this particular cases, we need to write the product terms. Okay, there is a product term we need to write in the case of SOP. Okay, and this is one case. 0 1 1, another case is 1 0 0, 1 1 0, and 1 1 1. So if you take the value 0 1 1, equivalent product term, okay, you can write here it is 0, okay, so a bar is equal to 1, okay, b is equal to 1, c is equal to 1, so output will be 1, okay. And another term is 1 0 0, okay, this is another term, okay, it's represented here. Here a is equal to 1, b bar is equal to 0, sorry, b bar should be is equal to 1, so b is equal to 0, so here also 1, here also function output is equal to 1, okay. For different case we need to write the product term, and we can combine all these things, so you'll get the standard SOP expression, okay. We'll combine all these results, so there will be 4 terms, 1 1 1, etc., okay. So now we'll see how we can write the POS expression from the two tables. So in order to write the POS expression from the two table, we will observe the function value when we will get 0, okay. So we are getting 1 0 3, 1 2 3 4, so 4 different cases. So we identified the 4 different cases where we will get the function value is equal to 0, okay. And we need to write the sum terms, okay, for which we are getting 0, okay. So first term is ABC, so we'll identify this ABC 0 0 0, so we can write a plus b plus c. So this is a sum term when a is equal to 0, b is equal to 0, and c is equal to 0, your output will be 0. And second term is 0 0 1, so 0 0 1 we need to get the output is equal to 0 when 0 0 1 occurs. So in this sum term, so a plus b plus c bar, so c is equal to 1, then c bar is equal to 0, so output is equal to 0. Then other term is 0 1 0, for 0 1 0, a b bar plus c, so because here b is equal to 1, so b bar is equal to 0. And the last term a bar and c bar, okay, should be 0, so a is equal to 1 and c is equal to 1, so output will be 0. And you can combine all these terms in a POS format, sum terms, 4 sum terms, and we are performing the AND operation, okay. And finally we'll conclude that one more point that is known as the min term and max terms. So when you write the SOP expressions, and we'll use this min terms concept, and max term will write the POS, that is this product terms in the SOP expression known as a min term, and the sum terms in POS expression is known as a max term, okay. Or in another way is that the terms, the product term which produce 1 is known as the min terms, and the sum term which gives 0 is known as the max term. So here you can see that for 0 0 0, for the variable x y z, the product term x bar y bar z bar will give you the output is equal to 1, okay. That is written here, instead of x bar it's x prime, like written. It's another representation. And the second term 0 0 1 is represented as x bar y bar z, okay. And similarly the third term x bar y z, okay, etc. So these are known as the min term. For this min terms the output value will be 1, so we need to write in this way, okay. This is a product term. Max term in the other side, which represents a POS form, so that is actually the sum term, okay. This is a product term actually, okay, sorry, this is a product term and this is a sum term. And here we need to get the function value is equal to 0. When the input is 0 0 0, the function value is equal to 0 when you write this particular sum term, x plus y plus z equal to, because x is equal to 0, y is equal to 0, z is equal to 0. And for the second term 0 0 1 should result into 0 by writing the sum term, that is x plus y, and the last term is z bar, okay. For this particular expression you will get 0. And in another way we can say that this is actually 0 1 2 3, 4, 5, 6, and 7. If it is a 3 variables, 0 to 7 values uh, actually representing the binary representation or decimal value 0 to 7. So I can represent the min term by small letter m and suffix 0. It's actually indicating min term 0, or the representation x bar, y bar, z bar, or we can say 0, 0, 0. And the other hand, the max term is normally will represented by the capital letter and suffix 0. Okay, so min term m7 and max term m7. Okay, min term m7 means x, y, z. Max term means x bar, y bar, z bar. Okay, thank you.